Hello everyone, welcome to the next lecture. In this lecture, we are going to learn about what are circuit elements. Okay, so circuit elements are basically the basic building blocks of a electrical circuit. Okay, so in order to form an electrical circuit, we use various kinds of circuit elements. For example, like resistor, inductor, capacitor, voltage sources or your current sources. They can be independent or dependent. So all these components forms an electrical circuit. Okay. So the first circuit we have, so the first element we have is your resistor. Okay, so what is resistor? So it is an element that has the property to resist the flow of electric charge. Okay, so the property of resisting electric charge is known as your resistance. Okay, that is expressed by the letter or symbol R. Okay, so this is the basic symbol of your resistor. Okay. So the SI unit, okay, so the SI unit of your resistance is in ohms, okay, expressed by this symbol, okay. Mathematically resistance is given as R is equal to rho L upon A, okay. So this is a very important formula and you need to remember it. And so what is rho? So rho stands for the resistivity, okay. So it stands for the resistivity and it is measured in ohm meters, okay. A is the area of the cross sectional, so area of cross section of wire, or you can say your resistor, okay. And L is the length of the resistor, so it is basically the length. So this is the length of the resistor, okay. For making resistor, we use various kinds of materials like carbon. Your next one is your ceramic, okay. So next one we have is the applications, okay. So applications, okay. So they are used in various kinds of, for example, in case of voltage dividers, okay. Then we have your current limiters, okay. Then we have your biasing circuits. In biasing circuits, they are used, okay. So these are some basic like applications of resistors, okay. Okay. So the next one we have is your inductor, okay. So inductor is basically a circuit element. It stores energy in form of magnetic field when a current is passed through it, okay. So basically it is basically a passive device. Passive means it does not have its own source of energy, and this property of storing energy in form of magnetic field is known as your inductance, okay. This is known as inductance and it is represented by the symbol called L, okay. Represented by the symbol L, okay. So this is the basic symbol of a resistor. So a coil with multiple turns, okay. And SI unit of resistor and SI unit of inductance is your Henry, okay, represented by the letter H, okay. And mathematically inductance is given as L is equal to mu naught mu R n square A by L, okay. So what is, so where your, so this is where mu naught is your permeability, okay, permeability of the medium, okay, of free space, and its value is equal to 4 pi into 10 raised to power minus 7 henries per meter. Mu R is your relative permeability, so it is basically your relative permeability. N is the number of turns, okay, number of turns of the coil, or you can say the inductor, number of turns, and L is the length of the inductor, where A is its cross-sectional area, okay, cross-sectional area, okay. So this is an important expression and you need to remember it, okay. So there are basically there are multiple applications where your inductors are used. For example, like in case of transformers, in case of your transformers, motors, okay, generators. Then we have in case of your filtering circuits to filter out like specific frequencies. Then in case of resonant circuits, okay, in case of resonant circuits, so there are multiple applications of your inductors, or you can say, okay, the next element we have over here is, okay, so the next element over here is your capacitor. Okay, so what is capacitor? So it is a device that is used to store energy in form of electric field whenever a charge flows through it. Okay, so basically it consists of two conducting plates. Okay, so a capacitor basically, so a capacitor consists of your two conducting plates, okay, which are separated by some kind of dielectric. So what is dielectric? Dielectric is a medium which is insulating in nature. Okay, so it can be air, it can be your plastic or wood, it can be like, so it can be air, it can be any kind of non-conducting or insulating medium. Okay, so we have various kinds of capacitors. For example, we have electrolytic capacitors or paper capacitor, depending upon the kind of application that we want to use it. So the SI unit for measuring capacitance, okay, is your farad. Okay, it is your farad expressed by the symbol F. Okay, so mathematically the capacitance of a capacitor is given as C is equal to epsilon naught epsilon R A by D. Okay, so here A is the area of the cross section of the conducting plates, and D is the distance between the plates. Okay, and what is epsilon R? It is basically the relative permittivity. Okay, so epsilon naught is your, so what is epsilon naught over here? So epsilon naught is the absolute permittivity. Okay, so it is the absolute permittivity, and its value is equal to 8.85 into 10 raised to power minus 12 farad per meter. Okay, epsilon R is your relative permittivity. Okay, so it is your relative permittivity and depends upon the medium. Okay, A is its your cross sectional area of the conducting plates. Okay, and D is the distance between the plates. It is the distance between the plates. Okay, plates of the capacitor. So this is also one of the most important expression, and you also need to remember it. Okay, so there are various kinds of applications of capacitors. Okay, for example, like they are used in case of like your resonant circuits. Okay, then we have your, they are also used in case of power factor improvement. Okay, in case of like filtering circuits to filter out specific frequencies, then in timing devices. Okay, timing devices. Okay, so that's all for today, guys. Please do subscribe to the channel. It will motivate me to make more such videos. Thank you.